Hi all, welcome back to the channel. Today we are going to start the first problem from the blind 75 playlist, and the problem today we are going to pick is two sum. So the problem goes like we will be given an array of integers nums, array of integer num, and we have to find an integer target. So we have to find two such numbers, let's say a, b, which will add up to make the target. So let's say in this example, as you can see, I have to find 9. So I can clearly see if I pick 2 and if I pick 7, then they can sum it, they can get added up to make this 9, right? We have to return their indices. So we have to return the indices of 2 and 7, which is 0 comma 1. Okay, we can return it in any order. So we can return 1 comma 0 as well. That will be also correct. Another thing is they are saying that there will be only one solution of this. So we should not worry about whenever we'll get the solution, we'll just return it. Another thing is we may not use same element twice. Let's say if I have been given, let's say if I have been given, let's say I have been given 3 comma 3 comma 5, and I have to make the target as 6. So I can't take this 3 twice. I mean the 3 which is at the 0th place, I can't take this twice. I can take this one which is at one place, one index, right? I can take that, but at the same index, I can't take that element twice. So that is that thing, right? So how we can solve it? So the very intuitive way to solve this would be we can start taking a number and trying to see, we should try to see the combination with every other number. So for this example, if I take 2, I can take all of this 3, 1, 5, 8, 4 and see if it is making adding up to make this number. So we can take 2 plus 3, which is 5, and we can take 2 plus 1, 2 plus 5, 2 plus 8, 2 plus 4. So any of these is not making 12, right? So we are not reaching it. So we basically what we are doing for every number here, we are trying to compare it. We are trying to add this up with every other number in the array, rest of the number. So for every n element, we are basically literally adding this to every other n minus 1 element. So this will be the time complexity which is coming around n square, right? So if I write the pseudo code of this, then what we are going to do is we'll start from 0 and we'll go till the length I plus plus, and then we'll see that other numbers are adding this to this number or not. So we'll start from I, and this j will go till the length j plus plus, and then we will see if array of I plus array of j is equal to target, then we can return this ij. So we have to make sure that we start this j from I plus 1, because if you can see that we are starting from 2, then we are trying to see every other number, right? Then when we start from 3, we'll try to compare it with every other number which are after 3, like 1, 5, 8, 4. So we are not going to check this again with 2, because when we were checking for 2, we have already checked for 2 plus 3. So no need to check 3 plus 2 it again, right? So this is the thing, but this is coming in n square. What we can do better? So one thing you might have observed that somehow if we know whatever have occurred already, and we can whatever number we have traversed before, we can use that to our advantage. So let's say we have to find here target 12, and right now I am at 2. So if I have 10 already before, so I can easily find out that we can get 12 from here, right? So we can maybe store it in some data structure called map. So map will be storing it in a way that we will be storing the index, or rather the number and the index, as a key value pair. So the key will be the value, and index will be the index of occurrence, right? So if I take this example here, 2, 3, first we will come across 2, right? So we will try to see whether we have the complement of 2 or not. So what I meant by complement is like we have to reach to 12. So what I already have 2. So to reach 12, I need another 10. So in my map, I can check whether I already have visited 10, but here I'm not seeing any entry with 10. So basically, literally, we are not finding the answer here. So we'll move forward and we'll just try to store this 2. So we'll store this 2 and the index is 0, right? Then we will go at 3. Now to reach 12, what I need? I need 12 minus 3, that is 9. I will see whether I do have 9 here. No, I don't have 9 here. So I'll just store the 3 with its index. Similarly for 1, I will try to see whether I have 11. So I don't have 11. I'll just store 1 here with the index. Then I will reach and I will see 8. For 8 to reach 12 from 8, what I need is I need 4, but I don't have 4. So I'll just store 8 here. 8, and then now I have 4. So what I need to reach 12? I need 12. 12 minus 4, that is 8. So I need 8. Here I'll see in the map that I already have 8. So yeah, I got it. So I can just return the current index. Current index is 4. And what is the index of 12? Sorry, what is the index of 8? That is 3. So I can return either 4 comma 3 or 3 comma 4. So that's how we are going to solve it. So map is helping us in finding the values which have already occurred. So I am interested in finding the complement of the values, because if I have to reach the target, I need the complement, right? So that's how we are going to solve it. So now we are going to code this up. So to start, what we can do, we can take a map. So I'm naming it as num map, and then we will loop through the array till the length. Now I'll try to see whether I have the complement inside my map. So first I need to see what is the complement for this number. So that will come from target minus nums of I. That is my complement. If my map has that complement, if my map has that complement, that means I got the answer. I already have my complement. So what I can return? I can return the current index, which is I, and I can return the complements index, which I would have stored inside the map, right? Now I will just return it from here because I got the answer. I'll not know, there will be only one solution, right? So I don't have to check for the next set of pairs. Let's say if I don't find the solution, then I should store the current value in the map, which I can do from setting this current number, that is nums of I, comma, the index of this position. And after this loop, we are guaranteed to have an answer. So we don't need to return something from here because we are guaranteed to return something from here. Let's run it. It is working fine. Now let's submit it. And this works too. Cool. So yeah, this is how we have solved it. So we have improved from a brute force solution of n square to map solution. And as you can see from the hash map, we can get the element in O of one time. So if we have to find, we have to get this element, we can find it in O of one. So literally, if I talk about the time complexity of this solution, I'm just looping once through the array. So that means it is a O of n solution. So time complexity would come around O of n, and that is very efficient. So thanks a lot guys for watching this video, and please, if you like the video, please subscribe it. That helps to make more such videos. Bye and see you in the next video.